Alright, today we're going to use our factoring skills in order to find out what the zeros are, or what the roots are, or x-intercepts, where this graph is going to cross the x-axis. And then we're going to sketch a graph. It doesn't have to be perfect, but we're just going to get an idea. So, for example, with something like this, because it's x to the third and because it's positive, we know that our graph is going to look something like this. We don't know exactly how it's going to look, but we know it's going to have that sort of shape. The other thing we have too is that we know that this is our y-intercept. So that -12 is our constant. So that's where the graph is going to cross the y-axis. Now, we need to factor. Remember that when you see four terms, one thing you want to look for is factor by grouping. When you factor by grouping, we're going to group the first two terms together and then the second two terms together. So factor by grouping, I need the greatest common factor in my first group. The only thing I can take out of here are two x's from each term. So my GCF is x squared. After I factor that out, I get 4x minus 3. And how we know we did this right is because if I multiply this x squared to each term on the inside of the parentheses, I would get back to my original. So x squared times 4x is 4x to the third. X squared times the -3 is -3x squared. And then finally, the other factor that I'm going to factor out is a positive 4. So the greatest common factor between 16 and 12 is 4. And what I have left after I factor that out or divide each term by that 4 is I am left with a 4x minus 3. What we should notice, and what should give us confidence that we did this right, is that if what's inside my parentheses is the same, that's a good indicator that we did this right. Now, finally, the last step is to take our common factors and put them in their own set of parentheses, so x squared plus 4. And then the factors that they have in common in their own set, so 4x minus 3. And what we're going to do is set this equal to 0 to find the zeros, to find the x-intercepts. How we do that is what's called the zero product property. You don't have to know that term quite yet. But I'm going to take each set of parentheses, so each factor, x squared plus 4, and set it equal to 0 individually. And then 4x minus 3 and set that equal to 0. And then we're going to solve each equation individually. When I solve this, I'm going to subtract 4 from both sides, so I get x squared equals a -4. How I undo a square is by taking the square root. So I'm left with x equals, remember, anytime we take the square root, we always are going to do plus or minus. We know the square root of 4 is 2, but we cannot take the square root of a negative. So what happens is we get plus or minus 2i. And so this is our answer. And what this means is that we have two areas of our graph where this is not going to cross the x-axis. Now, we are expecting to get 3 total answers because of our highest exponent being a 3. 2 of them fall right here, and it's not going to cross the x-axis. And where those occur are at the positive 2i and the negative 2i, and that's what that plus or minus means. That's where we get our 2 answers. Now, when we solve for this one, after I add 3, I get 4x equals 3. And then when I divide by 4, I get that x equals 3 over 4, or 0.75, 3/4, however you want to write that. So we have 3 answers, which we knew from our highest exponent. The first one means that this is going to cross the x-axis at 3 over 4, or 0.75. And these are not going to cross the x-axis at all, but we have 3 answers, 1, 2, and then 3. When we go ahead and make our graph, we want to keep in mind of this y-intercept, right? So this y-intercept down here at -12, so this is -12, that is where the graph is going to cross the y-axis. We also know that it's going to cross at 0.75 or 3/4, and the other two we don't really know. So I need this shape to show up on this graph that's going to go through these 2 points. And so the best way we can think of it is maybe the little hump occurs down here, and then that goes up forever. And so something like this would be acceptable on a test or a quiz or your homework assignment. So it carries the general shape of an x to the third graph going through the y-intercept at -12 and through the 0 we found at 0.75 or 3/4. We're going to do this one more time over here with number 2. Now I have 3 terms here, so we're going to factor in kind of the typical way that we'd factor a trinomial. And that is, we're going to find our 2 numbers that multiply to a positive 36 that at the same time are going to add to a negative 13. That means we need a negative times a negative to equal that positive. And so 9 times 4 is 36. So what I'm going to do is I'm going to have x squared minus 9 and x squared minus 4. X squared times x squared gets me back to x to the 4th. We already said that a negative 9 times a negative 4 is equal to a positive 36. And a negative 9 plus a negative 4 gets me that negative 13. And so this is the correct way to factor this problem. But remember that we need to find the zeros. So we're going to set it equal to 0 and solve each factor individually. So I'm going to take x squared minus 9 and set that equal to 0. And then x squared minus 4 and set that equal to 0. From there, I'm going to add or solve for x from both sides. So I add 9, and I get x squared equals 9. And here, after I add 4, I get that x squared equals 4. So to undo our squaring, we're going to take the square root of both sides. And so here, don't forget the plus or minus. I get plus or minus 3 and plus or minus 2. So again, we're expecting 4 solutions or 4 zeros because our highest exponent is a 4. One of them is the positive 3. One of them is negative 3. And then a third is positive 2. And the fourth is negative 2. Now notice how our y-intercept up here is a positive 36. So that means in our makeshift graph, we're going to cross somewhere up here when y is 36. So that's a pretty large y-intercept, comparatively speaking. Now, our solutions, or our zeros, or our roots, or x-intercepts, are going to be here at negative 3 and negative 2, and then also positive 3 and positive 2. Now let's think about, what does x to the 4th typically look like? It's a positive x to the 4th. So this is that W shape that opens up, right? The end behavior is going to infinity, positive infinity, in both directions as x approaches positive and negative infinity. And so because we're opening up and it kind of looks like this W shape, how can I go through all of these 4 x-intercepts and the y-intercept and make it look like that? Well, I have to start at the top left. So I'm going to start at the top left and kind of come down. And notice how we still maintain this W shape that goes through the x-intercepts, through the y-intercept, and still maintains the shape of x to the 4th.